Good morning, students. So today we are discuss about preparation methods of alkyl halides from alcohols. So this is the session number 4. Okay, so first preparation of alkyl halides from alcohols. From alcohols there are 4 methods. So first one, ZnCl2 plus HCl. So this is a Lucas reagent. So second one, sodium bromide, NaBr and H2SO4. This is second method. Next third one, reaction with PCl5. So fourth one, a reaction with SOCl2. Okay, so already this method discussion in yesterday session. Okay, so now today we are discuss these 3 methods. Okay, alcohols react with sodium bromide in presence of H2SO4. Alcohols react with PCl5. Okay, next method, alcohols react with sulfonyl chloride. So this is also called as Darzy's method. Okay, Darzy's method. Okay, Darzy's methods. So now, so already this is reaction. This is a discussion in yesterday session. So now we are discuss this one, NaBr and H2SO4. Okay, so here, so I can take propanol CH, propanol. Okay, sodium bromide and H2SO4. So here generally alkyl halides are obtained. Okay, alkyl halides are obtained. So here H2SO4, okay, H2SO4, that is a strong electrolyte. So in this reaction H2SO4 acts as a strong electrolyte. So what is a strong electrolyte? So strong electrolyte means the species which can completely dissociate in aqueous solutions. So here H2SO4 acts as a acid. So acid means which provide the H plus ions in aqueous solution, and HSO4 minus and HSO4 minus. So we know that, so here propanol is there, propanol. So oxygen has 2 lone pairs. So H2SO4 provides H plus ion. So H plus ion, this is a electrophile and a Lewis acid. Okay, electron acceptors are called Lewis acid. So here H plus acts as a Lewis acid, electron acceptor, because of it has empty orbital. So here oxygen has lone pair. So this is lone pairs donated to the empty orbital of a proton. So we get oxonium ion. So I can write just a minute, CH2 and CH3, propanol. Okay, CH2. This is the oxonium ion. So oxygen gets positive charge. So if more electronegative element contains positive charge, that will be unstable. Okay, so that's why electron displacement towards oxygen. So here water molecule is eliminated. Okay, water molecule is eliminated. So we get one intermediate, that is the carbocation. CH, carbocation. So carbocation. So generally any reaction, if carbocation formed as intermediate, in that reaction carbocation rearranges. That means less stable carbocation rearranges to more stable carbocation. So here I can write this is another way. Just a minute. This is a primary carbocation. So generally primary carbocation rearranges to secondary carbocation. That means less stable carbocation rearranges to more stable carbocation. Here H minus shifted is there. Hydride ion shift takes place. That means H minus displacement to here. So we get CH3 secondary carbocation. So this is a secondary carbocation. So here, okay, so I can use the sodium bromide. Okay, sodium bromide. Sodium bromide is a polar compound. This is a polar compound. Polar compound. So polar compound, that means Na plus and Br minus. Okay, Br minus. So here this Na plus bind with HSO4 minus. So remaining Br minus. Okay, Br minus. This Br minus act as a nucleophile attack on here. So we get two bromopropane. Okay, two bromopropanes. So here generally examiner, so two options are given, CH3, one bromopropane and two bromopropane. Two bromopropane. So which one is the correct? Two bromopropane is correct because of in that reaction carbocation formed as intermediate. That's why rearrangement takes place. The less stable carbocation rearranges to more stable carbocation. This is a Br, sorry. Okay. So this is the another preparation methods of alkyl halide from alcohols. So I can take one more example. So one more example. One more example. So here sodium bromide and H2 SO4. So which product are obtained? Okay, which product are obtained? So here also, then first I can write mechanism. So first H2SO4, this is the acid, so which provides H plus and HSO4 minus. Okay, so this is the alcohol. Alcohol. So here oxygen has two lone pairs. So this H plus ion acts as a Lewis acid or electron acceptor. So empty orbital, this electron donated to here. So we get oxonium ion. So oxygen has positive charge. Okay, oxygen has positive charge. So if more electronegative element contains positive charge, that will be unstable, then electron displacement towards oxygen. So we get carbocation. So we get carbocation. So H2O molecule is eliminated. Okay, H2O molecule eliminated. So here we know that, so generally 4-membered ring are less stable when compared to the 5-membered ring. So this is a 4-membered ring. So in any reaction, if carbocation is formed as intermediate, if ring rearrangement also possible, carbocation rearrangement also possible, and ring rearrangement, that means ring expansion, it may be ring compression. Okay, so here ring expansion is possible. This is a 4-membered ring. Okay, this is a 4-membered ring expansion possible. So can write, assign the number. So this is the first one, second, next to third, fourth, fifth. So in that compound, so what will happen? Ring expansion is possible. So how to ring expansion? So here bond breaking between, okay, bond breaks between 2 and third position. Okay, bond makes between 1 and third. Okay, next charge. So positive charge, okay, positive charge shifted first position to second position. Okay, first position to second position. So here first bond breaks between the 2 and third position. This bond will be breaks. Okay, next 1,3 bond will be makes. Okay, so here charge, positive charge shift first position to second position. That means this charge shifted to first position. So we get another compound. We get rearranged structure. So here bond breaks between 1 and third position. Okay, so 1 and third position, bond breaks between 1 and third position, bond breaks between 2 and third position. Charge shifted from 1 to second position. This is the first carbon, second connected to fifth connected to fourth connected to third. Okay, so here charge shifted from first position to second position. Okay, first position to second positions. So we get another way. I can write another way this structure. So how many this is a 5-membered ring. Okay, 5-membered ring. So this is the first carbon. So given to us number first carbon, first connected to second and third. This is the second, this is the third connected to fourth, 4 connected to 5, so 5 connected to 2. So charge shifted second position. This is a positive charge. So here we know that this is the polar compound. So under Na plus and Br minus. This Br minus acts as a nucleophile. This Br minus attack on here. So we get this compound. This compound. Okay, so this is a preparation of alkyl halides from alcohol. Second method in presence of sodium bromide and sulfuric acid. Okay, sulfuric acid. So next one, okay, so this method also over. So next react with PCl5. Alcohols react with PCl5. Okay, alcohols react with PCl5. So next third one, alcohols react with PCl5, phosphorus pentachloride. Okay, phosphorus pentachloride. So here I can write R, general reaction. This is the alcohol ROH. Okay, ROH react with PCl5. Okay, PCl5. So here, so we get alkyl halides in the sense RCl, alkyl chloride. Okay, so next to POCl3 plus HCl. Okay, so this is the alkyl halide. So we know that PCl5 structure. Okay, PCl5 structure. So PCl5 contains 5 chlorine atoms. In 5 chlorine atoms, there are 2 types of chlorine atoms. Is there 2 chlorine atoms are equatorial, so 2 chlorine atoms are axial, 3 chlorine atoms are equatorial chlorines. Okay, so here, so I can write balance the equation. Just a minute. Okay, so here how many chlorines? 5 chlorines is there. So 1, 3, 4, 5. So next hydrogens, 1 hydrogen, 1 hydrogen. Next remaining 1 phosphorus, 1 phosphorus, 1 alkyl group, 1 alkyl. So we know that PCl5 structure is trigonal bipyramidal. So this is the phosphorus, okay, Cl, Cl, Cl. So these 4 atoms are present on the same plane. So 3 Cl atoms and 1 phosphorus present on the same plane. So remaining among this PCl5, 3 Cl atoms present on the same plane. So 1 Cl above the plane. This is the above the plane. So next one below the plane. Okay, below the plane. So in PCl5 molecules, there are 2 types of chlorine atoms is there. Okay, equatorial chlorines and axial chlorines. So first one, equatorial chlorines, Cl atoms. Second one, axial atoms. Okay, axial atoms. So here this chlorine atom and this chlorine atom. These 2 chlorine atoms are equatorial chlorines or axial chlorines. So generally this is the equatorial, this is also equatorial, this is also equatorial, this is the axial, this is also axial. Okay, so axial chlorine atom means the chlorine atoms which are present above the and below the plane, that atoms are called axial chlorine atoms. Okay, so the chlorine atoms which are present on the plane, that chlorine atoms are called equatorial chlorines. So here this reaction takes place. Here 1 chlorine is there, so this is the 1 chlorine. These 2 chlorines are axial chlorines or equatorial chlorines. Okay, these 2 chlorines are axial chlorines. So axial chlorines. So because of this chlorine has 3 lone pairs. Okay, this chlorine also 3 lone pairs. Every chlorine has 3 lone pairs. So lone pairs. So here this chlorine also 3 lone pairs. So axial chlorine atoms repulsion with 3 equatorial chlorine atoms. So suppose this is a central atom phosphorus, 2 chlorine atoms and this chlorine atoms. These 3 are equatorial chlorines above the plane. The top chlorine is the axial. This chlorine equal distance to these 3 chlorines. So here repulsions arises between the equatorial chlorine and the axial chlorine. So that's why bond length increases. So bond length increases between the phosphorus and axial chlorine atoms. So generally axial chlorine atoms are more bond length. Okay, so bond length phosphorus and axial chlorine is more than phosphorus equatorial chlorine. So here which is the more bond length? This is a, suppose I can write A, this is the A, okay, this is also A. So this is the B type bond, this is a B type, this is a B type. So which bond length is more bond length? So due to the repulsions between the equatorial chlorine and axial chlorine, so bond length of axial chlorine and phosphorus increases. So that's why PCl axial is more bond length than PCl. So that's why this chlorine easily break up. Okay, bond length is more, bond energy is less. So that's why these 2 axial chlorines easily leave from the phosphorus. These 2 chlorines, 1 chlorine bind with alkyl group produced as a alkyl halide. Okay, so 1 chlorine bind with hydrogen eliminated as HCl. Okay, this is a alcohol's reaction of PCl5. So I can write one more example. So just ethyl alcohol. Okay, ethyl alcohol. Okay, ethyl alcohol. So react with PCl5. So we get ethanol. Ethanol plus phosphorus oxychloride plus HCl. Okay, so this is the third method. Okay, next to fourth one. Okay, so alcohols. Okay, preparation of alkyl halides from alcohols. Fourth method. Okay, fourth method, Darison reaction. Okay, fourth one, Darison's reaction. Okay, Darison's reaction. Darison's reaction. So here alcohols R bond OH. Okay, R bond OH react with SOCl2. SOCl2. Okay, SOCl2. So we get alkyl halide RCl plus SO2 plus HCl. Okay, HCl. So here SO2 present in the gaseous state. So HCl also present in the gaseous state. Okay, so this reaction takes place in a vessel. Okay, this reaction takes place in a vessel. So here these two are present in the gaseous state, so that's why these two gases easily escape from the vessel. So only leftover alkyl halide in that vessel. So this is the best preparation methods of alkyl halide. Okay, this is the best preparation methods of alkyl halide because of byproducts formed in the gaseous state. So gases are easily volatile nature, easily escaping nature, so left only alkyl halide. This is the best preparation method for preparation of alkyl halides. Okay, so here mechanism. So mechanism. So SOCl. Okay, this is a SOCl. Okay, SOCl2. Then ROH. Okay, ROH. So generally, so here oxygen is more electronegative when compared to the sulfur. So that's why electron displacement towards oxygen. Oxygen gets partial negative charge. Sulfur get partial positive charge. So here oxygen has lone pairs. Okay, this is act as a nucleophile. So generally nucleophile attack on electrophilic center. So electron displacement towards sulfur and again electron displacement towards here. So we get Cl O minus and O R and H. Okay, H. So here oxygen gets positive charge. Okay, oxygen gets positive charge. So here again oxygen positive charge, so that will be unstable. Then electron displacement towards oxygen, H plus ion is leaved. Again these electron displacement towards here, Cl minus is leaved. So here H plus and Cl minus byproduct eliminated as HCl, so which is present in the gaseous state. Okay, which is present in the gaseous state. So we get Cl, yes, double bond O, then O R. Okay, O R. So here Cl is the best leaving group. So then oxygen is lone pair. So again electron displacement towards here due to the support of entropy, heat. Electron displacement towards here, oxygen gets positive charge, then Cl minus is leave. So we get S double bond O, double bond, oxygen gets positive charge. So if oxygen has more electronegative element but positive charge is there, then electron displacement towards here, so R plus is leaved. So this R plus and here Cl minus is leaved, byproduct is, so here SO2 gas eliminate as a product. So R plus and Cl minus we get alkyl halide. Okay, this is a Darisen method. Okay, so it is the important one because of it is the best preparation methods of alkyl halides. So due to byproducts form in the form of a gaseous state, so that's why easily escape out the vessel. Okay, so these are the preparation methods of alkyl halide from alcohols. So next, one more important, okay, this is a very important. Okay, so alkyl halide to alkyl halides, alkyl halide to alkyl halides. Okay, alkyl halide to alkyl halide, alkyl halides. So alkyl halides to alkyl halides. So here there are two methods. So first one is Finkelstein reaction. Okay, Finkelstein reactions. Okay, Finkelstein reaction. Finkelstein reactions. Okay, second one which is Schwarz reaction. Okay, Schwarz reaction. Okay, Schwarz reactions. So here first one Finkelstein reaction. Okay, Finkelstein reaction. So in these reactions we can prepare only alkyl iodides, only alkyl iodides. So here reagent is, okay, reagent is sodium iodide and acetone. So this is the acetone. Okay, so here alkyl halide, so X only, X equals to Cl and bromine. So alkyl fluorides never react with acetone. Alkyl chloride or alkyl bromides react with Na and acetone to produce alkyl iodides. Okay, alkyl iodides, R bond I plus, so here X replaced by the iodine. So next byproduct is NaX. So this is the Finkelstein reaction. So reactant also alkyl halide, so product also alkyl halides, alkyl halide to alkyl halide. So in Finkelstein, by using the Finkelstein reactions we can prepare only alkyl iodide, only alkyl iodide. This is a Finkelstein reaction. So next Schwarz reaction. So in this reaction also prepared we can alkyl halide to alkyl halides. Okay, so here I can take alkyl halide. Okay, alkyl halide. So here reagent is silver fluoride. Okay, silver fluoride or mercurous fluoride, or stibine fluoride, okay, or cobalt difluoride. So any reagents react with alkyl halides to produce alkyl fluorides. Okay, alkyl fluorides, RF. Okay, RF. We can use AgF, byproduct is AgX. Okay, we can use mercury, mercurous fluoride, so byproduct is Hg2X2. So we can use stibine trifluoride, byproduct is SbX3. So we can use COF2, we get COX2. So this is the, just a minute. Okay, so product is alkyl fluoride. So we can use the AgF, byproduct is AgF. Sir, byproduct is, just a minute, AgX. We can use mercurous fluoride, so mercurous alide byproduct. We can use stibine fluoride, we can get stibine trifluoride, just a minute, SbX3. We can use cobalt difluoride, byproduct is cobalt dihalide. Okay, this is the Schwarz reactions. By using these two reactions, we can prepare alkyl halides from alkyl halides. So in this reaction, we can prepare only alkyl fluorides. So in this reaction, we can prepare only alkyl iodides. Okay, alkyl iodides. Okay, next preparation method, preparation of alkyl halides from carbonyl compounds. Okay, carbonyl compounds. Okay, sixth method, from carbonyl compounds. Carbonyl compounds. So we know that what are the carbonyl compounds? So carbonyl compounds, the compounds which contain C double bond O functional group, that compounds are called carbonyl compounds. So if this carbonyl group, both side hydrogens, which is called formaldehyde. So the carbonyl group contains one side hydrogen, another side alkyl, this is the aldehyde. The carbonyl group which contains both side alkyl group, that is a ketone. Okay, this is a ketone. So if carbonyl compound contains one hydrogen, one alkyl group, that is a aldehyde. So next, what is a formaldehyde? The carbonyl group which contains both side hydrogen atom, that is a formaldehyde. Okay, formaldehyde. Okay, so no need. So here from carbonyl compounds, we have prepared alkyl halides. Okay, so here can take carbonyl compounds R C double bond O H. So this is a aldehyde. So aldehydes react with PBr5. Okay, phosphorus pentabromide. Okay, phosphorus pentabromide. So here two halogens replaced by the, here oxygen atom replaced by the two halogen atoms. Okay, so we get R, Br and Brh. So byproduct is POCl3. Okay, PO, just a minute, POBr3. POBr3. Okay, so this is the gem dihalides or vicinal halides. So two halogen atoms, okay, two halogen atoms present on the same carbon atom. So that's why this is called gem dihalide. Okay, gem dihalide. Okay, gem dihalide. Okay, similarly ketones. So ketone or bond R. So here also react with PbR5. So in that reaction, this oxygen atom replaced by the two bromine atoms. Okay, two bromine atoms. So we get RCR. So this oxygen replaced by the two bromine atoms. So Br and Br. So we get POBr3. Okay. So this is also gem dihalide. So because of two halogen atoms present on the same carbon. Okay, this is the preparation methods of alkyl halide from carbonyl compounds. Okay, so next last preparation method. Okay, last preparation method, Unser-Decker reactions. Okay, Unser-Decker reaction, seventh one. Okay, Unser-Decker reaction. Unser-Decker reaction. Okay, Unser-Decker reaction. So here in that reaction, which type of compounds are participated? So here silver salt of carboxylic acids. Okay, silver salts of carboxylic acids are participate in that reactions. Okay, silver salt of carboxylic acids. CH3 COO minus Ag plus. So this is the silver salt of carboxylic acids. Okay, react with the bromine Br2 in presence of non-polar solvent. Okay, CCl4 is non-polar solvent because of a dipole moment is 0. So that's why this is a non-polar solvent. So which products are obtained? Okay, which products are obtained? So here, so generally I can take general reaction RCOO, silver salt of carboxylic acids. So in presence of react with Br2 in presence of CCl4. CCl4 is non-polar solvent. So which product is obtained? Okay, which product is obtained? So generally silver salt of carboxylic acid. So mechanism, silver salt of carboxylic acid. So generally CH3 COH. So this is the acetic acid. Okay, acetic acid. Acetic acid, the weak electrolyte. So weak electrolytes. So weak electrolyte. What is the weak electrolyte? So weak electrolyte in the sense the species which can partially dissociate into their respective ions in aqueous solutions. So partially dissociated into O minus and H plus. Okay, this is the acid. So what is a conjugate acid base pair? The pair which is differ by one proton is called conjugated acid base pair. So what is the difference between the two species? These two species. What is the difference between the two species? So one proton is the differences. Okay, one proton is a differences. So that's why these two are conjugated acid base pairs. Okay, so here this is the weak electrolyte. Okay, weak electrolyte. So weak electrolyte conjugate base is strong. Okay, conjugate base is strong. Okay, conjugate base is strong. So that's why this is a strong electrolyte which can easily undergoes to ionizations. RC double bond O minus and Ag plus. Okay, Ag plus. Okay, Ag plus. So this is a first step 1. So next I can take step 2. So here RC double bond O minus. This is the stable one. So here Br2 minus is there. Br2 minus is there. Okay, Br2. So here non-polar solvent is there. So whenever this negative charge moves towards here, Br minus is leaved. Okay, Br minus is leaved. So we get R C double bond O and Br. So this Br minus and Ag plus byproduct eliminated as AgBr. So here, so this is the oxygen and bromine. So here electronegativity difference less than 1.7. So that's why that is a covalent bond. Okay, covalent bond. In this reaction we can use it to heat also. Okay, heat also. So in presence of heat, homolytic fission takes place because of electronegativity difference between the oxygen and bromine less than 1.7. So we know that electronegativities of highest electronegativity element is fluorine. Okay, next before fluorine, oxygen, so nitrogen, next carbon, so I can write hydrogen. So next fluorine, chlorine, bromine, then iodine. Okay, so here highest electronegative element is fluorine. Fluorine electronegativity is 4.0. So just before fluorine 3.5. So nitrogen 3. Okay, next to carbon 2.5. So hydrogen 2.1. So next to nitrogen group, so phosphorus is there. So phosphorus also 2.1, similar to hydrogen, nearly same 2.1. So next oxygen, sulfur also nearly 3 points. Okay, next to bromine 2.8. so next to iodine 2.58. okay, 2.58, approximately 2.6. so here Br and oxygen, so difference between the electronegativity difference between the less than 1.7, that will be covalent bond. So covalent bond and heat also present, so that's why homolytic fission takes place. That means one electron displacement towards here, another electron displacement towards here. So we get R C double bond O, oxygen containing radical, and Br containing radical. Okay, Br containing radical. So here, due to the support of entropies, due to the heat, due to the presence of heat, it supports the entropy. So generally gases are more entropy than liquids. Then liquids are more entropy than solids. Okay, solids. So here, due to the support of entropy, so CO2 gas is eliminated. So here one electron displacement towards here, so here one electron displacement towards here. So these two electrons bind with the C double bond O. So here radical is there. Already this oxygen has radical. Next plus we get R radical. So these two radicals, okay, these two radicals combines to form CO2 gas. C double bond O, C double bond, CO2 gas. Due to the support of entropy, CO2 gas eliminated. So we left R radical and Br radicals. These two gives R Br. So here Br radical combines to here, so R Br, alkyl bromide system. So in first case, so what happened, instead of R I can write CH3, the product is CH3Br, alkyl bromide. So next here silver, here bromine is leaved, so byproduct is AgBr. So next here CO2 gas is eliminated, CO2 gas. Okay, so this is a Unser-Decker reaction. An Unser-Decker reaction, which species formed as a intermediate? So this is the intermediate. So alkyl radical is intermediate. Okay, intermediate. So what is the intermediate? What is the intermediate? The species, okay, the species which is obtained before the completion of reaction, that species is called free radicals. So here in that reaction, rate of reaction depends on stability of free radicals. So in that reaction, rate of reaction depends on stability of free radical. So rate is directly proportional to stability of free radical. Free radical. So that means rate is directly proportional to free radical, stability of free radical. If free radical stability increases, rate of reaction increases. Okay, rate of reaction increases. So I can take one more example. Silver salt of benzoic acid. Okay, silver salt of benzoic acid. Okay, silver salt of benzoic acid. So react with bromine in presence of CCl4. So which product is obtained? Okay, which product is obtained? So according to mechanism, so here what will happen in that mechanism? So here finally R radical is formed. Okay, R radical is formed. Okay, so R radical is formed. Okay, R radical is formed. That means here breaks takes place, and this is a free radical. Okay, this is a free radical. So then Br minus attack on here. So we get alkyl benzyl bromobenzene. We get bromobenzene plus AgBr plus CO. So here rate of reaction depends on stability of free radical. Rate of reaction depends on stability of free radicals. So I can ask some more questions. Okay. Ag. The silver salt of carboxylic acid. Okay, so this contains para position NO2 and para position CH3. Okay, so which is the more reactive in Unseriker reactions? Okay, which is the more reactive in Unseriker reaction? So this is the first one, this is the second one, so this is the third one. Okay, this is the third one. So this is the third one. Okay, so next, which is the more reactive in Unseriker reaction? So in Unseriker reaction, which species formed as intermediate? Free radical. Okay, free radical. So that's why rate of reaction depends on stability of free radicals. So here, which is the most stable free radical? So electron displacement towards here, electron displacement towards here. So we get benzyl free radical, CH2 free radical. Okay, so next here we get, according to mechanism, okay, so we get CH2 radical and NO2. So here so which is the most stable free radical? Which is the most stable free radical? So free radical is electron deficient species. It is stability similar to carbocation. So here this is a minus I group or minus M group or plus M group. This is the minus M group. Okay, minus M group. So this is a plus I group. Okay, there is no effect. Okay, so generally electron releasing groups. Okay, electron plus I means this is the electron releasing group. Okay, this is the minus I group, electron withdrawing group. Okay, so already incompleted octet, this is the electron withdrawing, stability is decreases. Okay, here stability is increases. So which is the most stable? So third one is more stable. Okay, third one is more stable than first one. Then here stability is decreases because of electron withdrawing group is there. So this is a less reactive. Second one is, sorry, just a minute. Second one is less reactive. Okay, second one is less reactive. Okay, less reactive. Okay, so this one. Next I can take one more example. Okay, one more example. Okay, so these three compounds, which is a more reactive in Unsediker reactions, So we know that Unsediker mechanism. So in Unsediker mechanism, carbocation formed, free radical formed as intermediate. So here one electron displacement here, another electron displacement towards here. So we get CH2 free radical. So next CH2 free radical. So here also which is the most stable free radical? Which is the most stable free radical? Okay, which is the most stable free radical? So here rate of reaction depends on stability of free radical. So here first, here which any plus M effect is there. So plus M effect increase the stability of carbocation. Okay, plus M effect. There is no plus M effect. Then check the plus IF, plus H. Okay, hyperconjugations. So here how many number of alpha hydrogens is there? Alpha hydrogens are 3 alpha hydrogens. So here this is the system adjacent carbon and alpha carbon. Here how many number of alpha hydrogens? So here only 2 hydrogens. So hydrogen, alpha hydrogens 2. Therefore alpha hydrogens 2. So here how many number of alpha hydrogen? This is the alpha carbon, only 1 alpha hydrogens. So alpha hydrogens increases, stability of free radical increases. So here which is the most stable free radical? Which is the most stable free radical? So this is the most stable free radical. So that's why rate of reaction, first one is more than second one more than third one. Okay, so these are the preparation methods of alkyl halides. Okay, so thank you everyone. So next session వచ్చేసి properties of alkyl halides. So we discuss about SN1, SN2, E1 and E2 reactions. Okay, so thank you everyone. సో క్లాసెస్ మీకు నచ్చినట్లయితే ఇంటర్మీడియట్ స్టూడెంట్స్కి షేర్ చేయండి. సో తెలుగు స్టేట్స్ ఎస్పెషల్లీ The class is content, so very excellent content, I hope. So anyway, watch and like and share, subscribe. Thank you.